So we got to hear from Elke yesterday, and you just got to hear from Mary Ellen, but we have three of our panelists who haven't had a chance to be introduced, and so I just want to give them a quick opportunity in a minute or two to just mention their affiliation and sort of their connections to these issues. So maybe we can start with Kimberly Warner, and then Suzanne, and then Brett can introduce yourselves.
Well, thank you very much. I'm Kimberly Warner, Senior Scientist at Oceana. And Oceana is the largest international advocacy organization dedicated solely to ocean conservation. We run science-based policy campaigns that advocate for solutions to problems that affect ocean's abundance and biodiversity. Oceana has protected over 4.5 million square miles of sensitive ocean habitat and won 200 victories to stop overfishing, habitat destruction, pollution, and the harming of threatened species. So we see plastic pollution as a growing threat to our world's oceans, as well as our food, health, and climate. We are alarmed at the large increase in plastic production that is projected to increase fourfold by 2050, and we think that this will only lead to more plastic in the ocean. Our focus is on single-use plastic products that are designed to last a lifetime, yet are often disposed of after only a single use. So Oceana is focused on stopping plastic pollution at its source. We're calling on companies to significantly reduce the amount of plastic they're putting into the market and offer plastic-free choices. And we're also calling for policy change that will require plastic production and use to be reduced at the company level. Thank you.
All right, thank you.
Good morning. I'm Suzanne Van Drunick. I'm with U.S. EPA's Office of Research and Development, ORD. And ORD is the research arm of the agency. We support the offices within EPA that make the policy. Within the Office of Research and Development, we have 4 national research programs on chemicals, air and energy, communities, and water. I'm the National Program Director for the Water Research Program. We cover watersheds, nutrients and harmful algal blooms, and drinking water infrastructure, or infrastructure that includes drinking water, wastewater, stormwater, and water reuse. So our microplastics work is in the watersheds topic of SSWR is our acronym. Rick Green is here. He is the lead for that topic area on watersheds. So I'm very happy to be here and have greatly enjoyed the discussions over the past 2 days.
Great. Yeah, Brett.
Hi, good morning. Brett Howard. I'm a director in the Regulatory and Technical Affairs Division at the American Chemistry Council. I just want to say thanks for inviting me. Happy to be here at the National Academies. Very honored and humbled to be a part of this excellent panel on new approaches to inform public health and policy decisions. Just a quick background, ACC has had a lot of initiatives that are focusing on plastic waste. We have a policy that we are supporting through our advocacy efforts to remove plastic waste. It doesn't belong in the environment, and to that end, we have a number of different programs on our plastic division side of the shop to support that. So we've got a number of ACC member companies that have committed to reuse, recycle, and recover plastic packaging. It's a 100% commitment by 2040, so happy to talk about that. I also have the Alliance to End Plastic Waste, which is focusing on a lot of the topics that we've discussed over the last day and a half, particularly infrastructure surrounding waste collection to help alleviate some of the burdens in our marine environments. But my side of the shop is a little bit more science-oriented. I've heard a lot of folks talk about the need for standards as far as sampling and analytical protocols. So one of the things that I'm personally involved in at ASTM and ISO, which are 2 national and international standards bodies, is the development of these protocols to help enable folks like yourselves and other academics to get data that can then feed into science-based risk assessments to help identify areas where microplastics may be causing a high risk, and then we can have additional science to support policy decisions to help alleviate those concerns. So looking forward to engaging in a great panel and talking about some of those initiatives. Thanks.
All right. Thank you all. So what I'd like to do, I will ask an initial question to get things started, but I'd like to invite those who may want to ask questions. You can go ahead and kind of make your way up to the microphones. People online can feel free to be submitting questions. So I'll ask my initial question, and then hopefully we can have as much time as possible for discussion. So please be thinking about your questions. So just to get us started, I wondered, we've talked a little bit over the past day and a half about various gaps in knowledge. We heard a little bit yesterday about lack of information in various foods. We talked about maybe focusing especially on the marine environment and not as much on the terrestrial, about maybe not knowing as much about smaller particles. But I just wondered what you all, from your perspectives, think are some of the most important gaps in our knowledge right now that we need to fill in order to effectively inform public health and policy decisions about microplastics. So maybe I'd like to give each of you an opportunity to comment on what you think some of those most important gaps might be. Would you like to start, Elke? Yeah.
Yeah, many thanks. I think we need really to understand the problem. Because what we would like to do as scientists in regulatory science, give advice to the policymakers, and it should be evidence-based, as we already said. We should not forget that very often we are ourselves emotional, and this is not really always dealing with clear and rational science, as it was mentioned by Mary Ellen. But I think we need to understand the problem, really. I mean, I refer now to microplastics, to the topic of the conference, yes. But you can put it on other issues as well. We need to understand, really, the contamination of our environment and in order to understand are we exposed or not, and then we need, in the same time, understand the hazards. And I think we are still far away from this. And, of course, we can do precaution. I mean, we have in the European Union, we have the plastic strategy. We have put out already some measures and also very ambitious targets with recyclability. But I think the gap still is to, understand the whole issue on the impact on health.
Thanks.
I think we probably do have enough evidence, at least in the oceans, to understand that at least macroplastics are having a devastating effect on many organisms, and plastic has this whole life cycle where it starts out really tiny, gets big, and then gets tiny and then tinier. And I think we're still trying to understand how all the biological processing of the microplastics, how those are maybe transforming some of these into nanoplastics. And I think we need to understand better the interaction of these microplastics with the microbial communities, both in the oceans and in our own microbiomes, to fully understand the health implications. But I think there's enough evidence to maybe suggest caution in how we use nanoplastics in medicines and other things, from what we know now. Thanks.
I agree with all that, and you've heard my comments so far. I would point to, maybe an analogy of where, I think we've talked about it a little bit already, but this is it's a new look, and I'm thinking back to the nanotechnology review. Some of the Environmental Defense Fund, I think, partnering with Dow or DuPont in a nanotech partnership. It was a great, partnership and collaboration, and I think we've got that opportunity here.
So from the public health perspective, I would probably start with a human health exposure assessment and really be able to evaluate what the relative contribution is from, we've heard different types of food, from air, from soil, from dust, and water, both tap water and bottled water. And what we haven't really talked about also are other beverages. There has been some work about microfibers and plastics in beer, but beer is not in a plastic bottle. So maybe to open our eyes and have a more comprehensive view of what the potential exposures are. From where I sit at EPA leading the water research program, I would probably focus first on a national public drinking water system assessment. And I could go through some steps of how I would approach that, so we can have a better idea of what is in the source water, what is in the treatment train, what is in the finished drinking water, and to be able to characterize what the size, the materials, the charge, et cetera, are. These could be anonymous samples because utilities would be more likely to provide information and participate if the samples were anonymous. But we would know what is the source water, what's going in, what's coming out. That would allow us to know what treatment technologies are most effective or least effective. And once we know what is actually in the finished drinking water, I think that would address some of the concerns we've heard about what are reasonable and realistic exposures. So if we were to start moving into the toxicity testing, we would at least have characterized, and I'm only speaking of public drinking water systems, we'd have a better idea of what we're really looking for. And eventually that could move on to premise plumbing, which is a different topic. And then FDA, they would need to look at the bottled water side. That isn't EPA's jurisdiction.
Thanks. Yeah, definitely wanted to echo some of the comments my fellow panelists have made. The exposure is a huge component, obviously, of a risk assessment that needs to be completed. And then, of course, the fate. I think some of you may have inferred from my earlier question that I am a chemist. It's true. I'm a synthetic organic chemist by training. So I'm going to add a little bit of chemistry nuance here. I think there was an interesting paper that came out of the Woods Hole Oceanographic Institute late last year from Colin Ward's lab about mineralization. So there's a lot of evidence that some polymers could be directly mineralized in the presence of UV light, particularly polystyrene. You've got that chromophore on there, which can accept UV, and the half-life of polystyrene is based on the calculations in this paper, much lower than the eons or millennia that some folks have postulated before. Of course, this is which environment is the polystyrene in? Those are all kinds of questions that need to be looked at as well. But suffice it to say, understanding how you go from not only the micro to the nano, but also nano to individual polymer strands. A carbon-carbon bond has got a lot of energy in it, so that's going to be very appetizing to something in the environment that's looking to get metabolic energy from endogenous particles. And so maybe there's an opportunity when you get down to that size that mineralization and biodegradation happens a little bit more readily, but we just don't have a good understanding of that at this point. I also wanted to mention that chemical recycling, it would be great to have more information about that. I think a number of companies have spent decades upon decades on making these plastics, but the deconstruction, as we saw earlier with the iridium-based catalysts and then the supercritical water, which, as I mentioned, that's really a nascent technology at this stage. So it's looking at chemical recycling in a way to create a circular plastic environment for production and recapture and providing value to what is essentially considered waste today, I think is going to be an important step.
Great. All right. Thank you all so much. Okay, so I'd like to go ahead and turn it over to you all to ask questions. And maybe Jennifer, would you like to get us started?
Yeah, so Jennifer Lynch. I am interested, probably mostly to Mary Ellen's, talking about international laws. So I read a newspaper clipping from 1988, and it was an ecological scientist who had traveled the world and seen plastic pollution in the oceans, and she was pretty devastated by it. It hurt to see that. And at the very end of her article, she commented that she had hope because of MARPOL. Because in 1988, they had just signed the Annex 5 of MARPOL, which is the International Convention to Reduce Pollution Coming from Ships. And the U.S. is a signatory on this. And I can say, looking back from 1988 to now, MARPOL didn't help us for plastic pollution in the ocean, although it should have, because ships are not allowed to dispose of plastic in the ocean, although they still do, and their enforcement is a problem. Is there an international strategy to prevent plastic pollution on land?
Interesting question. I am a U.S. environmental lawyer, but I will offer a few observations. Just like any statute, treaties are not consistently enforced. One of my favorite is the Montreal Protocol, right, for hydrofluorocarbons. We have had amazing success in treaties. We've also had disasters and failures. So with respect to your question, because every country has its own laws. It's got its own constitution. It is organically different. Every country is organically different. And they're organically different from one year to the next or one election cycle to the next, if there is an election, right? So, so your question was, is there an international strategy for dealing with plastic on land? And I would say, back to Brett's comment, that we need to begin with the end in mind. We need to think about taking our what we're calling trash. I actually call it post-use feedstock myself. but in looking at EPA's Environmental Protection Agency has led the world in many concepts for many, many years. And one of the early concepts in the RCRA program, where there's solid waste and there's hazardous waste, and a lot of folks were sham recycling. They were trying to call it recycling when it really wasn't, because really they just didn't want to spend the money to actually dispose of hazardous waste properly, right? They called it recycling. Well, in that construct, there's a 1998 Elizabeth Cotsworth memo that went through these criteria of the difference between a product and a waste. And right now, because there's a proliferation of too many different types of plastics, when you apply EPA's distinguishing elements between waste and product, it kind of does look more like a waste. It takes way too much money to actually recycle it and get value out of it, and that's sort of the calculation. But if we are more careful, if we can figure out how to retain the value of our post-use feedstock, of our polymers, by cutting back on the numerosity of polymers or rendering them somehow compatible for chemical recycling, that's the world solution. I mean, retain the value. You don't see people throwing aluminum away, but because it's a single substance, right? If we are able to pare back the variability and make the post-use feedstock more homogeneous, it will be valuable. It is valuable if we can do that. That would be my answer.
Do any of the other panelists want to comment on that at all? Like Mary Ellen's. Go ahead, Kimberly.
Well, I think, U.S. used to be an environmental leader in laws, and we've kind of fallen back in that position. But I do think that stronger national laws are needed. And perhaps if we have enough, we have the EU directive now, and maybe there will be something at some point in the United States that is comparable. But as enough countries rise to the occasion, maybe we can get an international movement in that direction.
Elke?
Maybe to add to this, not really a regulation law, but I think what we also need to mobilize much more, and we see this with the young population now, with the kids going on the road for the climate. I think the awareness raising as well everywhere, not just with the politicians and law, but I think if we all as consumers think more about sustainability. And then on the other hand side, I think, I don't know whether we will never have an international, agreement on incentives and what to do with the materials. I think we are far away of that, but I think we have to start also at the very much awareness raising on other levels. Not only leave it to politicians. I think it must be the citizens as well.
All right. Super. Gary, would you like to go ahead?
Yeah, Gary Ginsberg. When I'm on the checkout line, and they charge me a few pennies for using the store plastic bag, I always wonder, is there any kind of monetizable life cycle analysis behind, what are the real costs of that bag or that plastic bottle, whether it's involved in beach cleanups or effects on marine sea life, or, what's monetizable about the full life cycle of these plastics, and is there any research along those lines to help us think about this from an economic standpoint? And I guess a more specific question for Mary Ellen: is there any regulatory space where products can be seen from an environmental impact statement kind of perspective, so that we're always, at least in toxicology where I work, it seems like we're always 20 years behind the technology. I mean, the marketplace is changing, and there's different cell phones, or there's different ingredients in products that haven't been fully thought about and tested, and then we have something show up in NHANES, and we're caught as toxicologists without knowing everything about it. But if there was some trigger to do an environmental impact assessment of a new chemistry or a new product, so that we would be able to be out front on the technology and be able to analyze it first, I think that would just help us a lot, and not be cleaning up all this plastic waste without having thought about plastic may, in toxicology, we worry about PBV chemicals, persistent bioaccumulative and toxic PVT. This may not be so obviously the bioaccumulative and the toxic, but it is persistent. And, this could have been seen, I think, a long time ago, that it had a big P in front of it. Where was the environmental impact assessment of plastic as a technology or products that could have been thought more holistically about?
Yeah, so to your first point about the life cycle assessments, yeah, there have been a ton of LCAs done on the benefits of plastic. And I think one of the statistics we talk about at ACC, plastic is really lightweight, and so it cuts down on a lot of the CO2 emissions from like transporting food, right? It also extends the longevity of food. So those single wrap cucumbers that you see at the grocery store, you're like, why is this wrapped? That like triples the shelf life, which 40% of all food is thrown away. And so if we can reduce the amount of waste that we have, we reduce the impacts, the environmental impacts from that. And to that end, plastic does provide some benefit. The issue is, of course, the end of life, right, that needs to be addressed, which we've discussed.
And to your second point, I think I understood it. The concept that we would do environmental, in a sense, impact statement for new products. That was where I was going with Tosca. I mean, I think, and we are, okay. So my first job was in emergency response. I'm a little bit, reactive. We react to harm. We react to things. We react to things that blow up. We react to chemical plants that blow up in India. We react to things that we see, and we knee-jerk response. Look at the highest hazard. This is the opposite of that. I mean, it's just, we're just dealing with it. We just have reached a point of plastic, in our mass balance of a world where we're suddenly realizing we can't look anywhere without seeing it. I mean, we're sort of saturated. We've reached plastic saturation point, right? And so now we are considering that issue because of the perpetual nature of, and not quite as perpetual as I was thinking before this, this conference, but yeah, fairly perpetual. The P, as you say, should be considered in a TSCA evaluation. It right now, because we are reacting to toxicity and harm and acute risk, we don't actually do that. TSCA doesn't regulate food, right? The FDA regulates food, so TSCA is chemical products. I like the model of TSCA, though, because it's one of the few statutes where take a product, think of FIFRA, right? Which is take a product and it actually reaches to the distribution and the packaging and reformulation of distant use and says, if you violate this label, you're going to jail. I mean, not that people I'm sure do, but still that's the point. It is sort of a remote product stewardship model that might be helpful here. But again, we've just heard from Brett, quite rightly, that that these things that we think are maybe not necessary actually are a cost-benefit analysis of the food, which is also a huge waste. And in any case, it's really complex, which is why I'm so happy to see everybody here. It takes all stakeholders to fill in the gaps where we may not know everything, and we see this. But that's my thought Though there are TOSCA lawyers like Lynn Bergeson at Bergeson and Campbell who would be somebody we'd pull in for something like this.
Do any of the other panelists have thoughts on the environmental impact assessment aspect? Okay. Do we have a question over here?
Yeah, kind of related to that question. Oftentimes in risk assessment, we talk about fit for purpose risk assessment. And I'm glad that somebody brought up PBT assessment, right? Because that's the paradigm that drives in Europe and is sort of being exported to the rest of the world, for better or worse. And so my question is, right, fit for purpose. So for instance, metals. We don't assess metals under PBT because what's the persistence of aluminum? It exists in the Earth's crust. It'll be here long after we're gone. Right, but we still assess the risk of it. We still assess the hazards of those materials. And so I guess my question is, right, we're trying to squeeze potentially a square peg into a round hole. So there's got to be maybe some, and maybe you can comment on this, particularly Elke and maybe Mary Ellen, on the sort of fit for purpose application to microplastics, applying that traditional soluble chemical paradigm of hazard and risk assessment to a solid particle. And right, we have examples in the past where that sort of has and has not worked, right? Nanometals, for instance, right? So maybe you can comment on that more in the regulatory context.
Would you like to comment, Elke?
I think this is a very challenging question. Thanks a lot. I don't know whether we have enough knowledge on the issue of the microplastics and nanoplastic yet in order to understand whether we can take the traditional approach or not. And we had a discussion on the nanomaterials, and it's very challenging. I don't know whether we are ready yet with this, but maybe some of the colleagues from the panel can.
Well, back to the point of the point about metals. Well, it's persistent, bioaccumulative, and toxic. And again, we don't have the T. I mean, well, we're working on the T, right? We got the P and the B, but maybe not even bioaccumulative because the big parts go away, right? The little parts are the ones, the cellular, that penetrate the cellular membrane and some of the cellular processes. That's what we're really concerned about. But that's why I like Bart's presentation, because I do think that we're trying to get our arms around how to characterize a dose for something like this. It's not a chemical. Even copper, I mean, all the metals, the solids that we think of as solids, they are chemically toxic. We have a dose for them, right? We're trying to figure out how to think about a dose in this multidimensional construct. We just need a little bit more work here. And I do think that once we figure out that, we'll know where to go because we have our models.
All right, then, we have a question over here.
Yeah, I guess if I look at the situation, if I look at the situation from a citizen point of view and more umbrella, it seems to me that chemistry, 19th century, 20th century, was, basically used to support life and to support, eventually, my generation, the convenience in life. And now, basically, life is telling us, well, you are kind of using and abusing me, and I'm telling you. And so we have this type of evidence over and over and over. And so, yes, it's important as we act forward to have a baseline of agreement. But acting in the future, to me, is not a question anymore. Some, as Jennifer was alluding to, some see it in their face regularly. As a consumer, I see it in my face regularly. When I am told by, I believe it was Bruce from DOE that, 50 kilograms of plastic, is my waste, I have to reconcile with the fact that I really do not pay, for the economics of that. It's not I don't get the signal regularly. And so is there a possibility as we invest in research and development for upcycling and better recycling, because really right now recycling does not work, 15% most, it's not active, and we know very little about it. Then how can we get basically all the partners along the life cycle to become much more aware, and then refine on that? So I would like to have, I guess, the panel kind of react to that. What is 21st century, how are we going to use basically 21st century to give life a chance, knowing a little more about chemistry and how chemistry is part of life and can support life again?
Do we have any economists on the panel? Yeah, I mean, internalizing externalities, I think, is kind of what you're getting at, and that's an entire discipline in and of itself. I think, as we've discussed, putting a value on plastic at the end of life is one small step that we need to take to move in that direction. But it is a huge challenge for sure.
And thinking back to the point we were making earlier about preserving the value, starting with value, preserving the value, and because one of the tenets of EPA regulation is, why would we regulate like in the hazardous waste and solid waste, why would we regulate a product if the product has value? Because there's an incentive to manage it because it has value. Well, again, if we can get to the point where we know that the polymer has value because actually it could be, generate a lot lower greenhouse gas footprint if we actually, chemically recycle it successfully. It could be actually easier to utilize that. That I think is where we want to end up. But I also think that we have an opportunity now to pull everybody in together because of social media. I don't know if you may subscribe to like the Facebook Plastic Waste Network and stuff like that. I mean, everybody's trying to figure out a way to avoid plastic. Actually, plastic, again, it's really useful, and we can manage it better, right? I think that's where might be the way we can resolve some of our direction in the future.
I'd like to add that I think we talked a little bit in the last session about extended producer responsibility. I think that's one step to go in. But I think all along the value chain, society, governments have taken on the costs of a lot of these products that have been put on the market that maybe, we need to think holistically about along the whole product chain. How are the makers and producers accounting for end of life? And is it really taxpayers that are going to be burdened with this, or is it the producers? So I'd like to leave that thought.
But I think it is very important also to keep a very fine balance on all of this. I mean, towards chemistry, towards chemical substances. We should not be only keep this negative approach. We need to inform consumers. I mean, it is very important that we are a chemical factory ourselves, and that we don't have only this very negative approach towards whatever innovation and new products, and it has us making living much longer than in the past, whatever. I agree that we need to look much more careful maybe on our resources and how we as citizens and consumers have a more sustainable maybe consumption than we have now. Because now everything is easy and cheap, and maybe this is another thing. Maybe not everybody even can afford it, but we are very much a consuming citizens. I mean, it's so cheap you throw it away. It has no value we don't value maybe enough. But I would like to say that we should not always say, I mean, chemistry per se is bad or whatsoever, the products are bad. We need them.
Yes.
This issue is we face with also drinking water in the U.S. Compared to the rest of the world, drinking water is extremely cheap. And sometimes it takes more of a Facebook social approach for people to conserve water. And just as there's carbon footprint calculators, now there's water use calculators. And this summer when I was camping with my 12-year-old niece, we talked about your plastic pollution calculators, and just challenge yourself, challenge your friends, family, Facebook, on how you can reduce your plastic footprint.
All right, Greg.
Hello, I wanted to comment and then probably inquire a little bit more. I really do like the CIRCLA model, maybe because I started out also in emergency response. But I recall a day in early days of emergency response where we only looked at one PAH, and then we had 7, and then the Germans gave us 14, and now we have several. And we still made a difference. So we moved the needle, even in the old days when we had just a few PAHs to look at. Same with dioxin, same with CBDs. So, and it's only in recent times that we started to see the interaction between these as a soup that we're all exposed to. So I really want to say that even though arsenic is in many forms in the environment, it's only the one that was in with Olace that was really toxic. But yet we can still look at elemental arsenic in order to assess whether or not it's somewhat elevated. And with some protection in our evaluation, we can come to a conclusion that maybe we should reduce exposures in certain areas. So with that, if I can have some comments from the chemists and from all of you.
I am not a Superfund expert, so I'm going to dodge this question for now, and I will come back if I think of something.
Well, one thing I could point out, and this is fascinating to me as a student of legal history of United States environmental law, in promulgating the regulations and adopting SW 846 and identifying the analytes, right? All of that was preceded by rigorous industrial review and research and figuring out what are our top, not just biggest polluting industries, are the ones that contribute most to the economy, and the ones that are most toxic. I mean, our entire regulatory process is developed by prioritizing what is the most important thing. And all our analytes are surrogates for a family or an industry, right? So to that point, we may have limited, analyte lists for VOCs and SVOCs, and but they were all hotly debated for their surrogate representative, potential. And I think that, this again, plastic is not hazardous waste. It's not a hazardous substance, right? So I don't want to confuse anyone by referring to the CIRCLA model, but the CIRCLA model was intended to remediate, waste material in the wild, uncontrolled, abandoned, without a responsible party sitting out in the environment. And that is the aspect of Superfund I think is helpful. So with that, again, the point being, just because we might have a smaller family that we've decided is a priority, I think that we've got to figure out from a cost perspective and a management perspective, we've got to figure out how to move forward in a disciplined fashion, both in the manufacture and paring back on the heterogeneity of the polymers in commerce, but also when we're looking at the environmental impact and how to address it, we need to pare it back to something that makes sense, and look at surrogates or polymers that represent either uses or industries or persistence.
Any other comments? Did we have another question over there?
Thank you. Hi, I'm Julia Cohen again from the Plastic Pollution Coalition. We are a 10-year-old global coalition of over 1,000 organizations and nearly half businesses from 75 countries around the world, including Oceana and some others in the room. So thank you all so much. This has been an incredibly informative panel and day and a half, and we strive to be as accurate as possible when we refer to the science. But on social media and with the tens of thousands, if not millions of people we reach on a regular basis with our videos and memes and all those kinds of things, there's a lot of concern that 2050 is too late, and that we need to act now, and that the IPCC report and the youth movement and Fire Drill Fridays and climate strikes and all that, we've got 2 years to redirect the Titanic. So I appreciate all the scientists and the work that everyone does in this room. But my question for you all is going to be about timing. and systems change and policy. So a couple little angles for different panelists. The Basel Convention on Waste, there is conversation about labeling plastic or single-use plastic as waste. And that could happen actually fairly soon, potentially. The EU is obviously doing a lot more than the US right now. But in the next few weeks, there will be, for the first time, upstream federal legislation called the Break Free from Plastic Pollution Act, introduced by Senator Udall and Congressman Lowenthal. And then, in addition, the life cycle assessments are not taking into account, I mean, the database for LCAs is flawed. It is not the entire life cycle from extraction to waste management. So even how we judge those things has been difficult and flawed. And so I just think for all of those things, from European international conventions, federal legislation, to timing and policy to make change right now for citizens of this country, if each of you, or as many of you as possible, could respond to that, I'd appreciate it. Thank you.
Any panelists want to bite that off?
Well, I'll start. Thank you for the question. I think we really need to rethink how much more plastic is being produced now and projected in the Ohio Valley. And, do we really need to quadruple the amount of plastic that we have right now? Especially at this time when society is really pushing back. And there are a lot of uses that aren't critical, that are kind of, disposable throwaway that maybe we don't need. Maybe we don't need this incredible capacity that we're, embarking on now. Maybe we can slow that down until we figure out a way to handle all of the waste that we're currently unable to handle. So I agree that life cycle assessments have not adequately taken into account mismanaged plastic waste. There's no way to do that right now with the current models. So we need other ways of valuing and looking at maybe not so much a throwaway culture, but a reuse and culture. It wasn't that long ago that we lived without throwaway cultures. I'm old enough to remember those times. And, I think as other people on this panel have suggested, that through social media and increased awareness, that maybe we can get back to other times where we don't have such a disposable society. That would really help.
Okay.
We had a session this morning which was entitled Reducing Microplastics in the Environment. But again, we have discussed a lot about new products and recyclability, and often on macroplastic. It was more on macroplastic. And I think we need to understand, can we reduce out of the environment what we have already there? Can we get that out? Do we need to take it out? Or do we need to have measures, maybe nanoparticles? I don't think we will ever be able to get them out again. Again, we don't understand yet the impact on the environment or on human health. I think it is very important somewhere to have a plan how we are going to communicate this to citizens. Because even though a lot of research, which is coming now with lots of money, looking into monitoring and exposure and things like this, maybe one day we understand it's there, and it is there, and we don't understand yet the effects, but we need to do measures, and we have to communicate this clearly. I don't have a recipe for this, but I think this is very important and close to the heart of citizens to understand why maybe we take some measures. I mean, the macro litter and seeing that the birds are having it in their stomachs. But it's all about the more bigger things we see and less about the nano microplastics. And I think there we are missing, there's still a big gap to look into.
So we have about 3 minutes left. Those of you who are still in line, I'm hoping that maybe you could talk to some of the panelists afterwards, since we're near the end. If I could, I'd like to give each panelist just an opportunity as we wrap up to comment if you think there are areas where we already have enough information to highlight particular public health concerns or to motivate particular policy decisions as we go forward. And as you think about what we've heard over the course of the meeting, you might also draw in any experiences that we've seen in the rest of the world, whether you think the actions that the EU is taking are promising, or looking at other areas, whether it be responding to nano toxicology or those sorts of things. But I just want to give you each an opportunity as we wrap up to comment on if there was something that you would suggest moving forward based on what we've heard. Does anybody want to start us off?
Sure, I can start. I think one of the areas we already know a lot about this issue is, plastic is a valuable material, but how do we incentivize that on a policy level? That's something that we need to solve. So it's, not only is it reusable, but it's got a high BTU value. I know we haven't spoken a lot about energy recovery, but there are technologies where you could extract the thermal value from plastic, cement kilns, for example, to reduce the end-of-life issues. And incentivizing those is tricky. There's some issues with waste streams and that sort of thing, but there are opportunities there, and we have, I think, the basic knowledge to be able to support policy decisions that move in that direction.
I think what I was hearing earlier about the nanomedical device research that has loads of information. If you're designing an actual therapy, you're going to know everything about that material, and I think that the behavior is something we should mind to inform our risk assessment.
Yeah, I think the solution is to turn off the tap, of course, but certainly for the plastics that are already here, as we've learned from this panel, better understanding, the nanoplastics effects on the environment and on human health is really key.
I would agree to this, and then would add maybe to say that from a political point of view, we should look into incentives that really we have these recycled products more done, recyclability, whatever, bring together the stakeholders to leave it not just to the industry to come for new solutions. I think everybody has to work together, including the recyclers, and make that material then as well cheap enough to be used. I think that we need much more political incentives as well.
Right. And Suzanne?
And this kind of addresses your question about, the 2 years, not the 2050, is, a lot of work needs to be done that we've discussed in this room over the past 2 days, but what do we know? We know there's a lot of plastic out there. We could invest, internationally, we could invest in some of these technologies that are geared at removing the plastics that are already out there as we try and develop, better plastics, put more value on plastics. But what we can do right now, I know there was the Dutch effort to develop devices that can actually go out and collect plastics in the water. And, we can start there. We can start with trying to clean up, we're not going to be cleaning up the microplastics and the nanoplastics, but we can clean up some of the macro and megaplastics from which these micro and nanos originate. And, regulation is a long process. And I can tell you for EPA, we're not even thinking about it. We need to do these risk assessments first. But, that is effective is really at the local and the state level. And that's where we're seeing the banning of the plastic bags and banning of the straws, et cetera. So I think in the near term, 2 years, it's going to come at the local and state level.
All right. Well, will you join me in thanking our panel?